Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 261, Graph Valid Tree. This is a medium level graph problem, and today we're going to be doing this problem on Leetcode.io because this problem does require Leetcode Premium, which I don't have, so I'm going to be using Leetcode for this problem. And we're told that we're given n nodes labeled from 0 to n minus 1 and a list of undirected edges. Each edge is a pair of nodes, and we need to write a function to check whether these edges make up a valid tree. So we're basically given a bunch of nodes and we're told, do these make up a tree or not? How do we know if something makes up a tree? So let's look at this example. We've got 1, 2, and 3. Well, actually, let's make it more realistic. We've got a 0, 1, and 2. So is this a tree? Yes. That's a tree. That's a valid tree. There's no cycles, there's no loops at all. So we know this is a valid tree, and it's not like there's any other graphs which are part of this. So, everything is connected basically. There's no nodes which aren't connected, and there are no cycles. But what if I add an edge like that? Now we've got a cycle. Or if I add, 2 more nodes which are not connected to the tree. Well, this is not a valid tree either. So we need to make sure that there are no cycles and that there are no nodes which are not part of the tree or not part of the graph. So there should only be one graph component. So we're going to be solving this problem in C#, and compared to a lot of the other graph problems, it's relatively straightforward. We need to build an adjacency list and then look for cycles. However, there are a couple of things which can trip you up, and again, it is a Leetcode medium, so there is a level of complexity here. But let's get coding up. So we want to build up an adjacency list first of all. So we want to pass in a graph. Let's create a graph using a C# dictionary. We want to get each integer is going to be the node, and we're going to map it to a list of integers. Okay, and we want to say, let's iterate through each node. I is less than edges.length because it's an array, and we'll increment I. Okay, so that's our for loop done. And what we need to do now is say edges I 0. So each pair. So imagine we have our edges as x and y, so we're mapping x's to y and y's to x's. So it's going to be equal to 1, and we'll copy this over here. So we do the opposite. So now we have a valid adjacency list. So that's our adjacency list built. Now we need to create our hash set. So to be able to detect cycles, how are we going to detect cycles? Well, we need to have all our nodes that we visit in a hash set, and if we come across that node again, well, then we know that we have a duplicate. So, or we have a cycle. So let's get coding. Let's set our hash set equal to a new hash set of integers. Okay, and let's create our cycle. So let's create our depth first search function. I'm going to call it has cycle, just because it makes more sense that way. We're going to pass in a node as an integer and a parent node as a integer. So let me explain why we've got this parent node. So let's say, for example, we have 0, 1, 2, and over here is 3. Well, if we are going through this tree, going through our graph, we get to 1, so we look at all the nodes. Well, we're going to get 2 nodes. We're going to get 2, and from 1, we're going to get 0 again. So if we go back to 0, then we're obviously going to detect a cycle. So we want to pass in our parent. Oh, I shouldn't have done that. We want to pass in our parent. So we don't look up the tree again. We only look down to the 2, and then if there was a 1, if there was another node here, like let's say, I don't know, a 4, we would only look to the 4. We wouldn't look back up to the 2 because that's our parent node. So we don't look up to our parent node because otherwise we would just straight away get a duplicate, or our solution would class it as there being a cycle when there wouldn't be. So we need to pass in a parent node as well. And we want to say if our visited hash set contains a node, return true, because we've seen this node before, obviously. Otherwise, we're going to add this node to our hash set, and we want to increment through all the neighbors of our node. So let's copy and paste this. I don't want to write out a for loop again because I am a tad bit lazy. So we're going to get graph node dot count because we're using a list, not an array, and we want to say if graph node I is equal to parent, then we're not going to do anything. We're just going to continue because we don't want to class as our parent as a node that we need to visit. Otherwise, if has cycle graph node I, and let's pass in the node, return true. Otherwise, we're just going to return false. So we're going to return true if one of our other nodes has a cycle that we visit. So that is our has cycle, our depth first search function done. And now all we need to do is return not has cycle. So we pass in 0 and -1 as a parent because we have no parent from our first node. And we want to make sure that there is no cycle and that our visited count is equal to n. And this basically means that there is no unconnected nodes in our tree. And that should be all our code. So let's run our code. Let's make sure there are no errors. There probably may be, as I expected. I do tend to get errors. Okay, let's look through the code here. So we're building our adjacency list, iterating through edges.length. Okay. Cycle node graph node I node equals n. Okay, let's have a look. Okay, so it's to do with how we're adding neighbors in our adjacency list. So we need to actually add like this. We're just passing by reference. We're overriding our edges. So we want to add to our edges adjacency list. So that is an error with how we were building our adjacency list. Let's run our code again, and we also get an error. Cannot convert from integer. List int. Oh, I think I know what the problem here is. So before actually doing any of this, we want to build our adjacency list with actual integers. So we want to say for I equals 0. So basically we're trying to assign to lists that just don't exist. So we want to say I is less than n I plus plus. And graph I is going to be equal to a new list. So a new list of integers. Let's run our code again. And we're still getting compilation errors. The name I does not exist in the current context. Okay, so we have two issues here. We need to pass int, and we also need to add edges like this, not add the actual graph. Okay, let's check our code one more time. Hopefully this clears everything up. And we are still getting issues. I believe it's because of our square brackets. Finally, after a lot of hiccups, that was some literal DIY stuff right there. That's me programming a lot of the time. It's just breaking things and then trying to figure out why I broke it. Okay, fair enough. So we did manage to get this working. Apologies for all of that. That was a lot of debugging, and that was just me not paying attention to some of the details there. But we got it done. The time complexity, guys, is going to be big O of v plus e, and space complexity is going to also be big O of v plus e, where v and e are the number of vertices and edges in our graph. So with that being said, I hope you guys enjoyed this video and it made sense despite the little hiccups that we had at the end. And I'll catch you in the next one.